I'm going to try and help a bit with the notation, okay, for these sequences. So when we're writing down sequences, we would write, I'm just going to write a random sequence. So let's start at 1, and then 5, and then 9, a nice linear sequence. We like them, don't we? Okay. So we would say that this is the first term. So if I wrote down what n is, okay, so n here is the first term, this is the second term, this is the third term, this is the fourth term, and so on. So n is a counter, okay, and just a second, I'll just try and move this down a bit so we can see what's going on. And then finally our terms, so we would say that this is our first term is equal to 1, our second term is equal to 5, our third term is equal to 9, and our fourth term is equal to 13. Okay, so when you get un written down, then it means that the n here is the counter, the position. Okay, but the whole thing, un, okay, then that is the actual term. In this case, it's the nth term. Okay, so if you've got a sequence, you've got u1, u2, and you keep going, and then at some point you'll have the nth term. The one before that would be the n minus 1th term, the one after it would be the n plus 1th term, and so on. Okay, so that's how it works. Now, when you're given, in question 2, you're given term recurrence relations, that means you're relating the next term, so the n plus 1th term, to the one you're currently on, the nth term. So it gives you the term-to-term rule. All right. So this sequence, we start with u1, is equal to 1. So then u2 is going to be, according to this formula, 3 times u1. Okay, so that would be 3. And then u3 is going to be 3 times u2. So I'm just replacing n with 1, then 2, then 3, and writing down what it gives me. Okay? Okay, right. So hopefully that makes sense from there. And then the second part of this question is find a position to term formula. Yep, so that's kind of what you're used to from GCSE. So position to term formula, we need to have the nth term. Okay, so un is equal to something to do with n, which is the position. Okay, hopefully you can see here these are all powers of 3, so it's going to be 3 to the power of n. Let's just check that. If we do the first term, so u1 would be 3 to the power of 1, but that gives us 3, and we don't start on 3, that's our second term. So let's try the nth term is 3 to the n minus 1, okay, so then that would give us 3 to the 0, which is indeed 1, which is right. Okay, so the answer to part A there, this is our nth term. So it's an nth term, and a position to term formula, because n is the position. If you know the position, you can work out the term. So that's why it's a position to term formula. Okay. In question 4, it's kind of all the other way around. So you're given instead the nth term formula, the position to term formula, and you have to come up with a recurrence relation. So this one here, let's write out some the first 5 terms. If n is 1, okay, then t1, so they're using t instead of u. The first term is equal to 3 times 1 minus 1, which I'm hoping we can all do. Okay, and then let's try the second term. So the second term is 3 times 2 minus 1. So this time I don't need to know what came before. Okay, all I need to know is what position I'm at. So if I'm in the third position of the formula, I do 3 times 3 minus 1. Okay, so that's 8 and so on. So we can do those. Now, what we're now asked to do is get the recurrence relation. For a recurrence relation, we need a starting value. That's easy, just literally write down what the first one is. And then you need to have a recipe for getting the next number when you know the previous one. So your recurrence relation has to involve the nth term, okay, rather than the position n. Alright, now we can see this time we're always adding 3's because it's a lovely linear sequence. So if you take the previous number and you add 3, you get the next term in the sequence. So the real thing with the notation is that the n's are counters. They always start at 1 and go up in ones. 1, 2, 3, 4, and it just tells you what position you are in your sequence. Whereas the UNs and the TNs are the terms in the sequence. Okay, I hope this helps. If you've got any further questions, please do ask.